Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be metals, and this metals chapter is a pretty heavy one, and a lot of questions, a lot of points are directed to this chapter, so I will try to go as slowly, as clearly as possible. Firstly, the physical properties of metals would be these: good conductors of heat and electricity because of the metallic bond. Remember, metallic bond is metal cations with the valence shell delocalized into a sea of electrons. The electron particles are free to move around the cations, bringing the heat energy from one point to another quickly, or the electricity. And because of these, they are held closely together, causing them to have high density. A lot of energy is required to break them apart. High melting point, high boiling point. And because they are stacked in layers, they are malleable and ductile. Malleable means they are able to be hit into different shapes, and ductile being able to be pulled into wires. And as a result, being malleable and ductile, they are not commonly used for applications in the industries because pure metals are soft and they can corrode. Therefore, for application purposes, alloys are used. Alloys is a mixture of the metal with one or more other elements. So the common ones will be brass, copper and zinc, bronze, copper and tin, steel, iron and carbon, and these are other examples. And because alloys are a mixture, the different sized elements will disrupt the orderly arrangement of atoms, making it difficult for the layers to slide over each other. And moving on will be this very important list called the reactivity series. The reactivity series will be as such, and in the past, the older syllabus, it will be this. And if you want a combined list, you can go on to the internet to search for a collated one. It's not particularly important. If you want to know which one to know by heart, will be this one, the new one. And note that this metal reactivity series, there are two elements that are not metals. One is the carbon and one is the hydrogen. And why is that so? Because the ones above the carbon has to be extracted using electrolysis because they are considered to be very reactive. And for the ones in the middle, between C and H, can be extracted using reduction of carbon. The carbon, being more reactive than these, will be able to displace them, or as I like to tell my students, snatch boyfriend or snatch girlfriend, because you are more reactive. And those that are below hydrogen do not react with acids because acids are chemicals that produce hydrogen ions, and because they are below hydrogen, they are not reactive enough to displace hydrogen away from its anion. Therefore, these three do not react with acids. And because these three at the top are so reactive, they can react very violently with water, producing an alkali and hydrogen gas. And these ones in the middle will react with steam because they are not very reactive. You need more energy, more kinetic energy to bring the reaction across, and they will produce an oxide with hydrogen gas. And this is the mini laboratory setup to react metal with steam. And note that this reactivity series has this little mnemonic that says, please send camels, monkeys, zebra, large heavy crates soon. I don't quite like this one, so I will show you mine. Katrina and a cat must go to Charlie's zoo and feed the pigs, boars and hogs, winning a bronze, silver and gold medal. And I think this will give a better sequential storyline. So if you have other methods of doing so, you can comment down below. And this is a series you need to commit to memory because a lot of applications will require this skill set. So like mentioned, the first 3 or 4 will be extracted by electrolysis because they are very reactive. They hold on to their anions very tightly, and to successfully release them, you need to run electricity through them to extract these reactive metals. And in this chapter, there is this interest with the extraction of iron. And long story short, you need to know there are 5 equations. The key ingredient you need to use to reduce the iron ore will be carbon monoxide. You need to first generate carbon monoxide. First, you can remember it by brute memory, or for me, I would prefer to use a storyline method. I'd like to tell myself stories. So first you add the coke, which is the carbon, and you heat it with oxygen, you get this carbon dioxide, and you further heat with more carbon, you get carbon monoxide. Therefore, your key ingredient is generated. You use this carbon monoxide to reduce your hematite, your iron 3 oxide, and you will get your molten iron. And limestone, calcium carbonate, is also added because through heat, carbonates will decompose, producing carbon dioxide and its oxide. So calcium oxide is used to react with the silicon dioxide, which is sand, the impurities, to get your calcium silicate, which is your slag. So slag is the less dense one. It will be the one floating on top, and your molten iron will be the one below. So it is important to remember all these 5 equations. Okay, rusting. Rusting is a pretty small concept. There are 3 players required for rusting, which is iron, oxygen, and water that comes together and create rust, which is this. This equation is not too crucial, just that you need to know that rusting requires 3 players. You remove any one of them, there will be no rust. So sometimes questions like to ask you if you put it into boiled water, tendency is that it won't rust because boiled water has no more oxygen inside, and these are the other ways to prevent rust. Lastly, which is also another kind of environmental type of question, is about recycling metals, which I think is quite straightforward. I won't cover too much of it. One thing to note is that don't get the wrong idea that recycling metals is easy or cheap. It is not. So here are the advantages of recycling metals. Here are some issues related to recycling metals. And before I conclude this lesson, I think there is some appendix notes that I felt will be important to include into this video. I don't know where to put it, so I'll just put it at the back, and it'll be some random facts which will be very beneficial to know. So firstly, heating carbonates will give you carbon dioxide and its oxide, as mentioned in the topic of the blast furnace. Transition metals are the ones in the middle of the periodic table. They give color, and they have multiple oxidation states, and there's this topic of a lot of different kind of limestone, so slate lime is this. And for the topic of the alloys, if you add more carbon proportion in your steel alloy, you get a strong steel but brittle, or if you reduce the carbon proportion in your steel alloy, you'll get a weaker steel but malleable. Molten ores can conduct electricity because of the free moving electrons and cations. They can carry charges from one point to another to conduct the electrolysis, and because electrolysis needs to be conducted like that, a lot of electricity, a lot of energy needs to be channeled for this process to happen. That's why it's only more cost efficient and energy efficient to use this on very reactive metals. If those that can be reduced by carbon, the industries will let carbon do their job. And finally, about sacrificial metal. Because of the reactivity series, sometimes a more reactive metal is attached to the metal that is doing the main job, like for example a pipe or a ship hull, and to prevent it from rusting, we use a metal that is more reactive connected by a electrical wire to ensure that electrons can pass through. And once the main metal is being corroded, the sacrificial metal will channel its electrons to the corroded main metal, essentially corrodes in its position. Therefore, it is called sacrificial metal. And this is the equation that comes along with it. It releases the electrons for the main metal, sacrificing itself. That's why this equation looks like that. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!